Welcome back to another disaster. So I just finished editing this video that you're about to watch. So this is me from the future. And this video is not my finest work at all. I tried something different mentally and it just to me didn't work one lick. So I wanted to try to give some idea of my thought processes or processes as I moved from step to step. And that resulted in a lot of talking, and the video just didn't flow very well. So this one just a disaster. If you actually want to skip to most of the testing, I'd say you probably just skip an hour ahead ish or so, and that'll put you about the meat and potatoes of the video. And then also, you can probably play this back, or most of my videos the same. Just play it back at 2 times speed, and you ain't got to listen to me for quite as long. But there's a couple things that I wanted to go over now so that the video makes a little bit more sense. One thing is I got sidetracked for a really long time on this run crank relay, and that didn't have anything to do with the actual problem. I thought it did, but it didn't. So I cut out a lot of content and a lot of testing that was also tailored to that. So some of this is what I'm going to try to do now is fill in the gaps a little bit better. So I don't know how well you can see this. You don't have to know everything. But basically what we're looking at is ignition switch, body control module, CAN network, engine computer, and then the engine computer controls the actual starter relay itself. So this is the system that we're dealing with. And what I'm going to tell you now, so that hopefully the video flows a little better, because I think I deleted one of the parts of it. There's PID data about key status in the body control module. So there's a lot of PIDs, normal PIDs, where it says the key is in run, the key is in crank, it's an accessory, blah, 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 blah. I accidentally cut that part out and I have no idea where that part went, but I did test that specifically. The rest of it is a little all over the place, but the important part I'll leave you with is we made one call and we got the right call the first time. So all of the info that we used for testing was correct. And most all of my scope testing is with the ignition switch and the body controller. So really it was the ignition switch. I left the scope leads back probed in the ignition switch itself for a long time and through various testing. That really is what allowed me to pair together with the last piece of data that I got to make the right call. Anyway, this one's not my finest work, but if you want to watch it, it's here. Have fun, enjoy yourself, and get some popcorn, because it's a rolling disaster. Probably won't do it this way again. But hey, actually, you can comment here and let me know. I welcome feedback. Even if you don't like the video, you can tell me. That's fine. It is what it is. But I'll take some feedback and what you think as far as the content goes. If you like my thought process a little bit more, or you just want me to cut to the meat and potatoes, like this is what I'm doing now, this is what I did, this is what I did, and then bring you in after. Let me know, and have fun. Welcome back. So we have a '08 Silverado 1500. And complaint is some cranking issues. So it started off as a no crank, and then it was jump started, and it did start with a jump start, and then did that for a while. I think they drove it a couple times. It's not a daily vehicle. So after they jump started a couple times, then it no longer would jump start. It would not crank with or without jump starting it. So the starter was replaced, and it worked for 8 to 10 times. It cranked over and ran, and then it would not start after that 8 to 10 times. They removed and installed the starter cable. I think the starter cable, possibly battery cable, but I think the starter cable. And then it worked for a couple times and then wouldn't crank again. And then apparently I didn't write it in my notes, but the customer also said at some point they replaced the battery. I think after they jump started, they figured out it would work with a jump start. They put a new battery in it, and yeah, then I think it worked a couple times. I don't remember what we said after the battery happened, but so we got this kind of weird intermittent issue where we're not starting. I don't remember what phase the customer mentioned in here of having those parts replaced and cranking, not cranking, but he said that the lights would dim when they would crank it, like headlights would dim. So it sounds like we got current coming out of the battery, but in those cases it wouldn't crank. Um, but we don't know. I don't know if he was referring to that specific case, if that was before or after the battery and or starter was replaced. But somewhere in there, it seems to he noticed that the lights would dim, but wouldn't crank over like a dead battery. And then that's all I got. So when they drove it up, they left it running. They said they were able to jump start it to get it here and then left it running. So I took it out for a test drive. The engine drives fine. It's not misfiring. Very small, like exhaust manifold leak. It's got some aftermarket exhaust on it. But overall, the truck drives pretty well. So I don't see like any major engine stuff. Doesn't miss. I was kind of wondering if when he was explaining this to me, I was wondering if the engine was hard to turn over, if we had an engine issue, but it doesn't drive like it. It drives fine. But yeah, just want to know. So I haven't tried to start it since we did that test drive. I shut it off and did my little pre-check. And then we're going to jump in here, hook the tool up and see if it starts, see if we get any codes. Yeah, that's where we're at on this one. We are finishing up our pre-scan inside the truck. Got key on, engine off. I have not tried to start it yet. Looks like we got quite a few codes in these modules. There were no error messages or warning lights on the dash when I test drove it, so it says we're complete. We got fuel trim lane. That's interesting. Why? Since DTC cleared. I don't know if somebody else would have cleared these, and these are, yeah, there's no check engine light on, but this does have aftermarket exhaust, so that's interesting. Transfer case control module, neutral indicator circuit, loss of comm with BCM, loss of comm with brake control module, electronic brake control module, TCS malfunction, device 1 high voltage. It's kind of weird. I'm wondering, a lot of these, well, I don't know. I wonder if some of these happened when he was doing battery disconnects, low voltage, high voltage, like if he had like his battery was actually low. I don't know. It's kind of interesting what's up there. So mainly for engine stuff, we got fuel trims, and that's about it. So I'm gonna go ahead and save this real quick. Oh, I just got that file saved off. We're gonna see if she cranks according to the auto. We're just under 12 volts. Had the key on and off a couple times. This thing ran through an update on me. So overall, and I had the headlight on a few times, but we should be able to crank at 11.9. So key on, nothing. There it was. Okay, that reset. I don't think our voltage changed either, so we're going to crank. I don't know if I can get both of these. Oh, whatever. So we are in crank position, still at 11.9 volts, letting go of crank position, 12 volts. Go into crank position, return from crank position. Yeah, so this looks like all the dash lights go out, but that might have been what he was thinking when the lights dim. I think it might just cut power to the cluster stuff. So we're going to crank again. But yeah, I don't hear anything. We're not dropping voltage, so looks like we got no power to this starter. Let's recheck our engine codes, specifically reading codes. Maybe we're gonna, there it goes. So current and history. So we've got fuel trim, fuel trim, fuel trim. Go back one, see if this one does anything. Heated oxygen sensor resistance, engine coolant temperature performance, catalyst efficiency, evap. Oh, these are all not run though. Since cleared, or are those not run? Yeah, not run. So these must be old codes that haven't run. I'm assuming a lot of the stuff got cleared out from the battery disconnect or battery replacement or whatever else. So that's that's quite. Holy cow! This is a lot of codes. Oh, I think that. Never mind. These are. I'm silly. I think these are just like GM status stuff. My bad. All right. Well, I think we're going to throw a battery charger on it because we're going to have the key on a lot, and then we're just going to have to get a wiring diagram and see what's part of the starting circuit. I hope y'all can hear me. I got a heater going. It's not very loud, but I'm cold, so it's gonna stay on. Overall, we got a pretty basic wiring diagram for our starter circuit. So ignition switch goes to body controller communicates to engine controller runs a relay to starter. Batteries there. Yeah, so this thing overall is pretty straightforward. This is probably going to be our easiest access point, so let's go pull that relay and probably stick some auxiliary. I got an auxiliary relay tester that will run in there so we can pin it out, or at least touch the pins while she's plugged in. See what those wires look like. I'm trying to say so and well and all of that stuff when I come back on here, because off camera it's like a couple minutes go by between. Whoops, are you guys okay? You just fell. Anyway, because I keep coming back to it, I'm like, oh, so continue the conversation, but for you it's not much of a delay. Anyway, so we're on starter. All I did was pulled up. I got a little pedestal that comes out, and then this relay, I said starter, I meant relay, but starter relay. This relay is nice because on the bottom side, like the actual pins, it has them labeled. So I just took a Sharpie and wrote which pin is which. And then this pedestal, we can actually get through and test each of the individual pins. These exposed pins here on the exterior are attached to the pins on the relay. I almost said so again. But all that means is, according to our cute little diagram here, we should have a fuse feeding pin 30, and then engine controller based on that looks like a ground, so pin 86 should be power when the key is switched. Let's test 30. Oops, I got a pin in my hand. Oh, I need a pin in my hand. Got our test light. Can you see our test light? You cannot see the test light. Let me get you in focus. Come on, guys. Why aren't you looking at the right stuff? You're slacking on me. Okay. Second favorite tool, test light. Connected to ground up there. We got little B+ terminals down here, so we got our light. And then what did I say we're going to test? I think I said 30. So 30 should be the load side coming from the mega fuse. And 30, that's 87, so 30 should be over here, so it should be this one here. So we do have power coming from our mega fuse. I think those are also labeled, but whatever. So we got power coming from the mega fuse. I guess we'll have to lay this test light here. Maybe not. I'm gonna have to get an alligator clip. Placeholder. Thanks for holding. So I'm just gonna clip this one pin there, and then I'm gonna clip that to the test light. And that way, so this is pin 87. I'll lay that down. Pin 87 is gonna be the power output, should go to the starter. So let's hit the key. See if that thing lights up. I don't know if I can see. Yeah, I can see. So key is in the run position, crank,
So we got no power coming out of the relay. We're off crank, we're in crank, we're out of crank, we're in crank, we're out of crank. No power coming out of the relay. Well, we are on path. So let's go to, I should make sure this connection's good. So I'm gonna disconnect this one here and just touch. Then we got a test light lighting up. So we got a good connection on our test lights. Let's go to pin 86, which will be this one over there. See if I can find it. Something just clicked under here. Oh, the headlights just went out. The headlights are on when I was cranking it. So now we're on pin 86. I don't know if you can see. So this is control side power coming from the engine control module. Let's see if that powers up. So we are in run, crank, no crank, crank, no crank. I expect that would be a problem since we have no power coming from the engine control module. That doesn't exactly line up with what they were saying though, as far as they were able to jump start it and it worked for a while. I guess it's just coincidence with it not working when they change stuff. I don't know. It doesn't quite line up, but we'll keep that in the back of our mind. So if we ain't got no power there, then where's the engine controller at here? I don't know, I'll find it. So I think probably the next easiest one, we could rip this whole fuse box out, but I think I'm gonna try to go to the engine controller next. I think we'll back probe that pin out there. I guess the other thing we could do is look for a data PID. Let's do that real quick. Let's look for a data PID and see if there's a crank command coming from body controller to engine controller. We are in the run position. Can you see? Oh, look at that mug. What a good looking mechanic. So let's go to live data. Live data. I assume we want electrical theft, auto trans cluster, just engine. I assume we want just engine. Sort that alphabetically. Oh wait, yeah, so we're in the powertrain control module. So let's see if there's a crank. Nope. Start. No. Alright, well, I'll just scroll through these. Blah blah. Ignition signal. It just looks like battery voltage. 11.41, 11.5. So that's not what we want. Nothing. Alright, well, that's fun. So let's go to the body controller and see if it has any live data for crank. Charging, chassis, cruise, doors, exterior, inputs. That sounds like the right one. Park brake, switch status, valet. Well, that was useless. Let's go back one. Live data. I really wanted to see some sort of, oh wait, remote start. Maybe that's got something. Sort. Battery voltage. Start status. ECM crank abort. That's an interesting one. Maybe we'll just check that. Head ajar. Ignition switch fault. No. Key in ignition. Show selected. I'm just going to run this to the crank position. I'm going to see if any of these change, even though it's remote start. So we're key on, engine off. We're in crank. Out of crank. Crank. Out of crank. No data PID changes on this. So here I was trying to be lazy with our diag. Chrysler's kind of nice on their newer stuff. They've got that bus input data PID list where you can see what modules are sending key messages that you'd be interested in for diag. I really like that. Doesn't look like Let's just check this, just in case. We don't have a theft light. And he said he jump started it to get it here. It's interesting. Oops. Come on. So disarmed. Head ajar. No. Okay. So it doesn't think it's being stolen, which makes sense. I didn't have any theft lights on when we were driving. Okay. Well, I thought I was being cool. Let me go find the PCM and the connectors and all that stuff.
I was still trying to be lazy, and we found this one. So in the body controller under active tests, we've got this run crank relay. So I don't know why it says on. It says it's in run. But we're going to try and flip this and see what happens. So perhaps it'll crank if it is working. Procedure in progress. On. Let's do off. We are still connected on the test light. So let's try that again. Let's hit on. We have nothing there. I don't know if this is actually doing anything. Let's turn it back off. Well, dang. I thought that'd be cool, but looks like we're still gonna be chasing something else. And yeah, that's about all I really found there. Okay, well, back to PCM stuff. I almost said so again. We have dug the scope out. We are back probed in what should be the correct wire of the engine control module, and we will see what happens when we go to crank. Took us a second to figure this out, so let's see if you guys can see with me. So depending on the package, we've got 3 different choices. If it's a diesel, we could have 1. If it's a 4.3 liter, which this is not, you could have option 2. If it's also a 4.3 liter, you could have option 3. This is a 5.3, so that's fun always when that's less than helpful there. When we go to the connector view for X1, we can go through each one of these pins. Somebody's making a lot of noise outside. So we go to the connector view. This yellow wire color is yellow and black. There's only one of these pins that lined up with yellow and black. It was that one down there, pin 52 or whatever. So that's where we're pinned at now. There, we'll let that scope screen reset, and we shall go into the crank position. I can't see anything, so we're key on. We are in crank, no crank, crank, no crank. What do we got? We have noise. Well, we may have a bad scope connection, as always, or we got something else going on. We're gonna retest this just a couple quick times with my wires. Make sure we're not back probed. Man, my back probe skills feels like lately it's really just been just lackluster. I don't know what's up with them at all. It feels like I can feel like the pin, like the middle pin. But let me go on the other side of this wire. While y'all are just having fun laughing at me while I waste time. Come on. I'm trying to go on the other side of this same wire. But you don't want to go in. There we go. Now we're on the other side of the wire. Man, I can feel like it's touching metal. So let's try her again. We're in crank, no crank, crank, no crank. We got no change. We're going to do one more test just to be safe, to make sure my back probing skills aren't falling apart. Yeah, especially with my track record lately. We're going to go ahead and Phil's probe this. So we'll jump this over with the Phil's probe just to make sure we're not missing something too obvious here. But if this test does not work, then it looks like we're going to the body controller to back probe the ignition switch wires where they come into the body controller. Okay, now we have a definitive good connection on this PCM wire. Yeah, make sure our scale's set right. Yeah, we're good there. So go back. We are in crank, no crank, crank, let go of crank. Okay, so we got no PCM output for sure, and we got, well, this camera's all crazy. So we have known good connection down there on our wire from there. So it looks like now we're going to go to body controller. Let me figure out where that thing's at and what those connectors look like. We'll pin into that. We are plugged into the body controller. So currently as it sits, we have, oh, I was trying to look at this piece of paper. So channel A is still on our PCM, Phil's probed in here. Channel B, which is green, is on pin 2, which this says pink, but it's actually pink and black. And the body controller's under next to the steering column under the dash. Channel 3, which is blue, is on pin 4, which is a white wire, which it is. However, this pin 4, I could not get my back probe in here, so we are Phil's probed in about an inch out from here. So we got a back probe in here, a Phil's probe here, and a Phil's probe here. We can see channel B is up to what I assume is battery voltage. We got a charger on it. So we're at 13 volts there. Yes, that looks good. Let's go in and see if I can avoid ripping all these wires out of the door. All right, key is off. Key is on in the run position. Key is in crank. Key is in run. Key is in crank. Key is in run. What do we have? Pause that. I gotta re-remember everything that I just said. Probably should have read it on here. So it's kind of a weird number to be on. What's with all of our weird numbers? So this is, oh, come on. It's falling apart. So right here, we are at 4 volts. Kind of an odd number, I think. I don't know why. Actually, let's blow this up. Make sure we're getting accurate. So I assume this first dip is when we keyed on, and then we cranked twice. We got 2 lows, but this is 3.89 volts. This here says 5 volts. I don't know if that's going to make a difference. What did we go down to here? Down to 2.85. So let me get 2 cursors in here actually. I don't know what this means. So it drops a volt. So we're at 3.92 volts on the top cursor, 2.91 volts on the bottom. So we have a 1 volt delta between these two. I have no idea if that is good enough or not. What do we have? We have ground essentially all the time. Oh, hang on. Am I looking at this backwards? I think I'm looking at this backwards. I was thinking we were on that one. I don't know. This is the trace we have. Let me start this. After I'm done thinking, we'll get you back on mine. We have a bunch of non-helpful information. Let me grab the original diagram. So the original diagram we're working off of shows 5 volts coming in, and then goes through a resistor, and then signals back to the body controller. I don't know really what this is supposed to be, so I went to the color redrawn diagrams, and it looks to be the same. So we've got our body controller. Can you see this? Our body controller right here. We've got white wire goes up, and it says 5 volts on the white wire. That goes up to our ignition switch, but in the start position, it goes through a resistor and then comes back to here. So we have one, probably, my freaking phone keeps cutting this off. So we have one of probably 3 things that can go wrong here. I'm gonna grab the original one, hopefully before my phone dies. So we could have, this is channel C, which one? Channel B was changing. So very likely this resistor is working. If this resistor wasn't working, we probably would not get some dips like this and changes. But I don't know what the voltage should be. This says 5 volts, but this is going from our 3.9 to 2.9. Regardless, what I think I'm going to try to do next is actually measure. So I'm going to unplug this body harness connector, and I'm going to measure these 2 pins resistance, because I want to see what this resistor value is. We'll go to this one for a little better, because so I need to know what that resistor value is. At least I want to measure that, because we could have really a few things going on here. If this resistor value is wrong, then the body controller isn't going to see the signal it wants back. So something in this circuit's bad, or the body controller is not sending out a CAN message to the engine controller, which we cannot find. This is why I like the Chrysler stuff, because they kind of give you that info. I can't find anything in PID data that tells us whether this message is working or not. And or we could have the engine controller just not turning on this circuit. So we could have circuit issue here, communication issue, which, circuit issue or body controller module issue. And then we could have PCM issue. So I don't know what we're going to do to decipher all those, but my next best bet is to start manipulating this thing here. Also, remember, they were able to jumpstart this, and it seemed to fix it a couple times. So we're probably going to tap on these, bang them with our fist and a screwdriver and see if that changes anything. But I think I'm going to unplug this connector, measure this resistance, and then if I can, I'm going to try and bridge these 2 wires with various resistances. So, we'll see various resistances here, and maybe see if we actually get the engine to crank. Yeah, this is where my mind's going next, because I don't have a good way at this point, because I don't know, the service info doesn't help. I don't know what that's supposed to be. It doesn't tell me what the voltage is supposed to be, but it's going to be one of these 3 things. We got a circuit issue here, a body controller issue, a communication issue, which is not likely. Either the body controller is not seeing it, or, sending it, or the PCM is just not turning that on. We got to figure out a way to try to isolate which one of these it is. Yeah, so this one should be entertaining. Here, I thought we were going to have an easy one. I have my next 3 tests planned. Took a little breather, went and made some dinner, so I had a couple minutes to think, because I didn't have a clear thought of how we're going to prove which one of these potential issues is actually the issue. So I am troubled by the fact that it says 5 volts coming from the body controller. This heater is hot. I'm troubled by the fact that it says 5 volts and that we have 3.1 volts, I think is what it was. 3.9 volts, and then it grounds when we crank. It drops by 1 volt. So 3.9. I'm troubled by that 3.9 number. Everything here says 5 volts. I'd like to see 5 there instead of 3.9. So just keeping that in the back of our mind. Point 2, with what customer was saying, he was able to get it going a few times when he would jump start it. So we got the battery charger on it. We're sitting at, 13 volts or whatever. What I might do is I might crank that up to the 50 amp setting, the jump start setting, and see if any of these readings that we're already scoped into change. And the third test that I'm going to do, was that 2 tests? Oh, so what I meant to say on the 5 volt thing that troubles me is, what I think I might do is unplug the ignition connector at the ignition switch and recheck that 5-volt ref from the body controller. I'd like to see if the ignition switch is pulling it down from 5 volts to 3.9 or whatever, or if the body controller is only putting out 3.9 volts. So I need to know which one's the case there. Is the body controller not putting out 5, or is the ignition switch pulling it down a little bit from 5? And then depending on what I find there, I've got this doohickey. So this takes a 12, so this takes a 12 volt input and converts it to a 5 volt, 3 amp max output. So as we are disconnecting these connectors, trying to figure out what our 5 volts is supposed to be from the body controller, whether it is supposed to be 5 or 3.9 or whatever, what we then may do is depin our 5 volt ref from the body controller, like take that pin out of the connector, push the connector back in, run our 5 volt generator to that wire, and then see what voltage we get, whether it pulls it back down to 3.9 or whatever. But those are my 3 thoughts now. I think we're gonna turn the jump pack up pretty high to the jump start setting, see if we get any voltage changes on the scope. Then we're going to unplug our ignition switch and see what our 5 volt signal looks like from the body controller, and then perhaps depin that 5 volt wire, and run our 5 volt generator on it. That's I don't really know how else to start doing testing here. We don't have we might, I really don't want to. We may get into some CAN analysis, and when I say CAN analysis, I don't mean sticking the scope on it. I actually mean data pack deconfiguring, like reverse engineering what it means. So if all of our stuff from the body controller is good, we need to know that the body controller is communicating the right message to the engine controller. And I'm going to recheck, if we get there, I'm going to recheck all of the menus on the body controller and the engine controller for all the PID data to see if I missed something, to see if the body controller is actually making the request for the engine controller to crank the engine. I really don't want to get all that old equipment out, but when you actually start scoping CAN wires, I assume this is CAN, it's an 08, it's probably a CAN wire, a CAN network. I don't think it'd be anything slower. Anyway, when you actually start scoping them, of course you see the square waves and yada, 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 and the 2 wires mirror each other, yada, yada, yada. That's not what I'm talking about. So the Autel has a function that I haven't actually used yet. I've used it on different tools, but you can actually break down those data packets, and you can see what the CAN IDs are. We won't know what they are from or to, because that's all proprietary information, but we can decode it into hex. We can take those binary switches, we can get the CAN ID frame, and then we can see the data packet of that CAN ID frame, and we can see if there's any signal changes when we go to crank on a given ID frame. If there's none, like if there's no ID, I should probably pull up an old file. You're going to think I'm crazy. This one's really, really for the nerds. I really don't want to go here, but just to try to explain what I'm saying, let me get something pulled up on a computer, and then and we'll start that. This is what an actual CAN frame looks like. So when you decode, what just happened? Okay. Back to, so I just Googled this because it's the same thing. I've got a file saved, but it's not on this computer. It's on an external hard drive. The way this works, when you have all the square waves, those data packets that you're looking at in like scope trace data, where you actually have a CAN bus down or CAN bus fault or something, if you convert those binary signals to hex, there's a structure to them. This is called a CAN ID. This says I'm from a certain module to a certain module. So this is the CAN ID I'm referring to, and then you've got your data bytes or your data packets that are converted from binary to hex. What we can watch is we can list. Like this we can do. We can ID all of the CAN IDs and then we can go from in the ignition switch run to ignition switch crank, and we can just see if any of these values change. Definitively, this is not a proof positive test, it's a proof negative, if you would. So, for example, if I monitor all the CAN IDs on this CAN bus and we have no change, like none of these values change at all when we go from run to crank, then we have definitive proof we have a failed body controller, assuming that we take care of all of our 5-volt testing. I do have tools that are buried to actually decode this stuff. The Autel is supposed to do it. I've never used it on the Autel. I've enabled it one time, but I haven't actually used it for a test, so we might try it on the Autel. If not, we might have to get some CAN analysis tools out, like actual reverse engineering tools, which is not my favorite because it's very difficult to do and very time consuming. Anyway, we can test that. And then, yeah. So this is what I was talking about when we're doing CAN testing. So what I think I'm going to do next, we're just going to go ahead and disconnect this ignition switch. Excuse me, I misspoke. We're going to crank it up to the high crank setting on the battery charger. We're going to probably actually also tap on a few things. I'm going to tap on the body controller, tap on the ignition switch, see if our scope values change, and then we'll start disconnecting ignition switches. Right now, state of everything, key is off. Let's see if we can't replay this. We've got, okay, that battery charger is now flipped up to 50 amps, which I see no change, probably because we've got a pretty good charge on this thing. It's been sitting for a while. Let's see. Yeah, we're at, it says 12.6. Why are we at 12.6? We have a smart battery charger. I guess it just turns itself off. Whatever. Let me give this a wiggle. Okay, battery charger made some noise, but I think it turned right back off. Well, let's just see if we can crank. So we'll go key on. We have no change out here. Let's go ahead and go to crank. Nothing. No crank. Crank. No crank. I assume we're going to see the same thing we did last time. Yeah, that looks about the same. So we're going from 3.9 to 2.9 or whatever. Right, let me grab a screwdriver. We're going to start tapping on stuff inside of here. I'm going to start by tapping on the ignition switch and the steering column. So we're going to hold and crank, and I'm going to start tapping on the steering column. I'm still on the crank, tapping on steering column. Nothing. Okay, so I'm going to have to now, I think, go lay underneath the dash. We're still on our boost setting, which now looks like it's drawing quite a bit of current. Yeah. So, where's my light? So now I'm going to lay underneath the dash, and I'm going to see if I can't tap on this body controller module. There she is. So I'm going to try and tap on this body control module while holding a crank. So we're in crank position. I'm going to tap. Getting no change. And we're tapping directly on it. Nothing. Okay. Well, while we're banging on stuff, I should probably bang on the engine controller, but I can't quite hold it in the crank position. I'm going to assume that we had a change here. I'm going to go back a screen. Come on, what happened to my data? Fucking Autel. Alright, well, that just aggravated me. Why aren't you? Well, that was useless. I'm going to have to watch the camera play back on that to see if anything actually changed. But anyway, let's tap on our engine controller. back of a screwdriver. Let's go ahead and see. Move to crank. Nothing. Alright, it's still dropping like it's supposed to. Tap on it again. It's like a good old knuckle dragger with that reset. Why is it not resetting? What happened? Why is my data frozen? We're going to do a scope reset. Whatever. Crank position, key off. That didn't look like anything helped. I also don't know why it spikes the way it does. So crank position, key off, dips. So it must go key on. I wonder if, oh, you know what, that makes, no, it doesn't make sense. Why do we have 12 volts on that wire? We shouldn't have 12 volts on that wire. Wait, oh, my bad. So green is channel B. So when we key on, so when we key on, we're getting 12 volts here. There must be another 12 volt feed that feeds this. I don't imagine 12 volts is coming from the body controller. Our next test, regardless of what we were going to do anyway, when we disconnect the ignition switch, we'll be able to confirm where that 12 volt is coming from. If it's coming from the ignition switch side, it fed power from somewhere else, or if this has a 12 volt ref that it changes. I don't know. I have no clue. Looks like we're going to unplug the ignition switch next and then run a couple tests there. Sometimes I really hate myself, but it is what it is. So I did some testing off camera because it was hard to drag you along for ignition switch circuit testing. So recall, we were testing stuff between the ignition switch and the body controller. I'm confident it's fine now. Let's flip this. Just running an intermediate test. I wanted to make sure that the scan tool commands were actually going out like they're supposed to. So we're in the engine controller in our active test just for the AC relay. And if I hit this, I can hear the relay click under the hood, and I can hear and see, turn it off, turn it on. So I can hear and see the relay click. I can also hear and see the clutch engage on the physical compressor. So I'm having more confidence in our output controls here. And so when we go back to our starter relay, these tests, I mean, it should work. So command state known, procedure in progress. This doesn't make sense. We have no emo codes. We have no problem there. Like, it doesn't, that's not an issue. And actually, here, we're going to do this real quick. If it was an immobilizer issue, if it wasn't an immobilizer issue, this thing should not start no matter what, like no matter what. So we have the key on, I believe we should. That's how we're just making everything work. So key is on, engine is off. Let's just actually manually energize this relay. So this relay. So there's where channel A is going to, and this goes to ground. So let's just send 12 volts on this relay. Let's do that through here. So we've got our test light. We'll disconnect it from this end. Just dangle it so it doesn't catch on weird stuff. So we'll take 12 volts from our test light. We should find ground, maybe ground there. So we got, you see that? Of course not. Of course you can't see anything. Come on, man. Thought you were keeping up with me. So test light's hooked up to this B plus post here. When we find ground, we get a lit test light. Still can't see it. There. Lit test light when we find ground. So I already forgot which pin I was supposed to be jumping. We're going to jump pin 86. 86 on our relay, and I wrote down all these numbers before, and of course, yeah, 86 is the one we had here. So when we touch these two together, this thing should really crank and fire. Let's see how bad this goes. I don't know why it didn't fire. Why wouldn't it fire? That's odd that it won't fire. I would have expected this to fire. Let's do one further. Oh, let's do one further test. Maybe, well, let's do a couple more. Let's make sure we didn't set a bunch of codes. I wonder if the ignition switch has to match our inputs. So run engine controller, hit trouble codes. The next one will do the same thing, but I'll put it in the run, I'll put the key in the crank position at the same time and see. So we have no trouble codes. Come on. No trouble codes. Okay. So let's do this again, but let's see if I can stretch this to where I can actually crank the engine over and touch these at the same time. Okay, start now. So key is now in crank, now touch test light. Why are we not starting? I don't know what's happening. I don't know why the engine isn't starting. That doesn't make sense. Let me think. I don't really remember where we left off with this. It's getting a little frustrated, and I started doing a bunch of testing. So, one of the things we talked about last time were, because, apparently I'm blind and I can't look at the right PID data in the body controller. But if we go to PID data in the body controller, like we did, we can see we've got key status change. We have no codes in the body controller when everything's plugged in like it's supposed to. When I unplug the ignition switch wires, like just depin them and reconnect it, we actually get codes. So what that tells me is our 5 volts, follow me through this nightmare. Our 5 volts from the body controller is not like 5 volts on engine controller. It is not a rough and tough 5 volts. It is a sensitive 5 volts. So whenever we go to the run and crank position, it goes from 3.9 to 2.9, 3.9 to 2.9. I'm gonna say that's normal. I can't find anything in service info about it, but I'm gonna say that's normal, just as far as I can tell. And like I said, when we depin one of those, we end up getting codes. I did check those, but when we put everything back together, we have no codes. So that tells me I think the body controller is seeing the ignition switch like it's supposed to. That puts us somewhere between the body controller and engine computer for the reason this thing won't fire up. So if the body controller is not sending the right CAN message to the engine controller, that would not allow it to start. If the engine controller is not just reading the CAN message from the body controller, then and or not turning on, obviously not turning on the control side of the relay, then it could be at fault. So we've got a couple things that I've been looking at. So I did pin into the network wires with the Autel, and if you remember when we looked at the computer screen with the CAN packets and whatnot, you can USB the Autel to the VCMI, and then the VCMI scope leads into the CAN channels, and then you can filter it down, sort it down, and actually start to see the CAN IDs. So let's flip you around. I'll show you that's what I got going on now. But before I do that, we can't use it this way. So if we were to reverse engineer this CAN network messaging from the body controller, I cannot do it with the Autel because it doesn't give me any filters. I can't export the data to Excel. It's just cycling through as it does. So let me get a different display. so you can see what we got going on. Our yellow channel D is hooked to one of the CAN networks at the engine controller. So let's flip this. So channel D, and if I zoom this in real far, and just pause it and go back a screen. That keeps deleting. Go back a few screens. There we go. So we can see, I'll move this down here. These are our normal CAN packets, our binary stuff that we were talking about. So Autel, when you USB in, you can do this CAN overlay. And if you remember all the weird stuff we were seeing on the computer, it will decode it for you. So I'm going to move this back up to here. So this is our CAN ID. So 1CD. So we have a 3 byte, so it's probably UDS protocol. We have a I misspoke. 3 alphanumeric digit CAN ID, and then we've got some data stuff about the CAN, which we're not going to get into at all. And then this big long frame here is our actual frame of data that's coming across CAN. But the problem is, so let me hold on this camera a little bit differently. So I'm going to hit play, and then we're going to zoom back out. I think it was 150, I don't know. And I got a phone call right in the middle of that explanation, so I don't really remember where we were. So we've zoomed out to 50 milliseconds per division, and so it's decoding all of those CAN frames, data packets, etc. I'm going to make this bigger. The problem is, so each one of these IDs are going to be from one specific module to another specific module. The intellectual property part that no one's ever going to give us is decoding these. So if I just hit pause or stop. So for example, 0C1 in hex, that's going to be from a given module to another module, and it's going to send all of this data across, and then that's how they communicate. But we don't know which ones are from the body controller to the engine controller. Likewise, multiples of these can be from the body controller to the engine controller, but we don't know which one contains the start message. So the only way that we can really figure this out is I got to dig up some old tool that I don't even know if works anymore. And what we can do is we can record everything that we've recorded now, and then we can unplug the body controller, record everything again, and then we'll have to dump all that data in Excel, and we'll get an ID list of a delta. So when the body controller is sending messages, some of these will show up. When we unplug the body controller, some of these will not show up. And then we could filter with the other tool. We can filter on just the delta messages and see if we have any changes in those when we go from run to crank. That's the only thing I can think to do, because like I don't know where else to go with these two. I'm assuming this circuitry is all good because we can read it via PID data. I just don't know if the body controller is not sending the message out. I'm kind of leaning towards PCM. This is just my live thought. I'm leaning towards the PCM because so back to these messages, if, for example, 0F1, if that's from the body controller to the engine controller, just as a random example, if this message disappears, no, I shouldn't say that either. Ignore everything I just said. I was going to say if that message disappears, this controller should set a code that says, hey, I'm missing a message from this. But it's not going to be missing. It's just going to be the data part. So the data bytes are going to be different. That's what we would look for. Man, I don't know. I don't know what's up with this. I'm really leaning either we got a body controller or an engine computer. And I don't know which it is. And I don't know how to test between these two. I don't know. We've got that weird emo reaction, immobilizer reaction when we try to do the starter relay control via PID data. That makes me suspicious. I don't know. I really don't know. We're gonna have to sit on this one for a while I think, because I don't know how to figure out which one's which or which one's the problem. recap. I know I've been doing way too much talking in this video, but I'm really trying to figure out what is happening, and I really want to drag you guys along with. I want it to be a good video. I want to try and save it. So I've printed off two more wiring diagrams that we got to look at. I've printed off both of them are part of the power distribution wiring. And we've got this run start, run crank. It's got a couple different names depending on what diagram you're looking at. But this run crank relay that appears to be body controller related, and a more detailed breakout of the ignition switch. So let's, I don't know how I'm going to do this. Let's flip you and try my best to bring you along. So, I don't even know where we should freaking start. Let's start here. Run crank relay. So, one control side goes to ground. Cool. The other control side comes from the body control module diagram N. So, move over here to diagram N. This is, in fact, the body control module. But this power side control for that relay goes straight through and comes from the ignition switch. So this is our actual ignition switch here. So when we are in run or start, we get pass through onto this circuit. And this comes from a 2 amp fuse under the fuse box. So 2 amp fuse to ignition switch to body controller to relay control side. So it looks like we're going to put scope wires on several of these channels. Specifically now I'm more interested in these three. So probably scope at least those, and then maybe all 4 of them even with crank, just to watch it. And then we'll probably put a test light. We'll do some test lighting over here and make sure that we get power to the control. That way I can monitor 5 at the same time. Because at the end of the day, if we can get it to screw up, which it's still working right now, but if we can get it to screw up, we should see one of these 4 wires have an issue on the scope, and or this test light should not light or will light. So like if it doesn't start, we have no screw up on a scope, and we have a test light, now we're looking at just a relay, which is cool. But bring it back. I'm going to repeat what I said earlier. When we were doing our starter relay triage, I couldn't figure out why it wouldn't fire. Even when I jumped the control side power to the starter relay, it cranked over. Let me show you what else this thing feeds. So back to our run crank relay. Whenever it is engaged, it feeds all kind of stuff, but I'm going to draw your attention to go across here to the ECM ignition fuse. If we don't have power to our ignition fuse for the engine controller, most certainly the engine won't fire, even if I jump the starter relay. And if we follow these down, we've got engine control fuse, fuel system control module, and I don't think that doesn't apply. But this controls ignition. So this would be for sure why it wasn't firing. If we weren't having power, well, obviously we weren't having power when I manually jumped it. But this has to be set for sure. We've got to have this one tripped over and our start relay engaged, obviously, to crank. It is a new day. We've got all our business stuff taken care of for today, so we can actually dedicate the rest of today to figuring out what's up with this truck. And based on our experience yesterday, we may very well need the rest of the day. This one's kicking my ass through and through. Have a couple new thoughts. and a couple of new steps that I'm going to do next. No idea where they're going to go, but we will try. So yesterday we had most of the day it wouldn't work, and then suddenly it started working, and I had the scope bouncing around to so many different places and tests. It was even hard for me to trace or track while I was doing it. So I'm sure it was probably even worse for, I don't know if it was bad for you or not. I guess you could pause the video. Couple thoughts. When yesterday, one of the things we did was tap on stuff just to see, harnesses, body controller, engine controller. We tapped on stuff, didn't have any results. But I'm going to do that test again. But this time, I want to hold the key in the crank position. So that way, that should be our quote failed state. So I'm going to hold it, figure out some way to hold it in the crank position while going through and tapping different things. That's going to be the next one. Here's our setup for the next test. So I just have some hose clamp pliers holding the key in the crank position, resting on the steering wheel. Hose clamp pliers are nice. They have a rounded jaw, so I'm not gouging that key or anything, and it's just enough to hold it in position loosely. So right now we are in the crank position. I guess I should probably be more gentle jumping around this car with that steering wheel there. Let's play this. So channel A and channel B should be at 12. They are. So this is confirmation. We are in the crank position. Body controller sees crank position. So at this point, I'm going to start here at the ignition switch. I actually probably should leave that scope running in the background. Actually, I'm going to do that, see if anything changes. But I'm going to start up here. I'm going to start wiggling from the ignition control or the ignition switch to body controller, powertrain controller. I'll set the scope on record and see what happens. That took a little bit longer than expected. Autel actually called me back on that scope buffer issue where you let it go through the page and then you page back and the data's gone. It's a bug in the new release, so they're supposed to push me a beta update. We'll see if that happens. Anyway, keys in crank position still. I push, pulled, wiggled everything from ignition switch wiring to the body controller wiring to the firewall wiring to the PDC, fuse box, whatever, and to the engine computer. And I'm not getting any change. So next test, I'm just going to figure out, or I'm probably going to take the scope and do a bunch of power checks on the engine computer, probably grounds while we're there. So we'll do power ground checks at the engine computer to see if it's not getting one of them. Because that's the only thing, from that perspective, it still catches my attention in the back of my mind, because I still don't understand why when we were in the run position yesterday and we cranked, like we jumped the starter relay, the engine cranked, but it wouldn't fire. I still don't understand why it wouldn't fire. Maybe the key has to be in the crank position for it to fire. Let's do that. We're in the crank position. We are instrumented on the starter relay. Let's give that a quick test. Currently, this was set up so that we were looking for power on the control side of the starter relay, but we're going to change that around so that we can actually issue power on the control side of the relay. I'm trying to figure out how to shut this truck off really fast if something bad goes wrong. So we are, what you can see, of course you can't see anything. So when this touches ground, is that ground? Maybe. Can you see this? There we go. So when we touch ground, it lights up. So we're sending power from here to the control side of the relay. So once we touch these two together, because it's wired there, the truck should crank. I'm going to make sure nothing's going to fall in the engine and kill me. So move this stuff out of the way. I'm going to double check the inside because I'm also going to want to be able to shut this thing off really fast. I think we'll just yank the wheel because we still have that hose clamp pliers holding the key. So if we yank the wheel, it should uncrank. Yep. All right, well, let's see what happens here. Oops, didn't make good connection. So starts and dies. So that part's interesting. Let's see if it'll do it again. So we had a start and a die. Let's go in. Oops. I'll go in here. We'll pull this out. Pull this out of the start position. So when all the lights come, so there's all the rest of the, maybe. Just let go. Okay. So now we're in the run position. Let's try and crank it. Nothing. So it started and died. Why would it start and die? But to me, that doesn't make total sense. I don't know why it would start and die. Let's try it one more time. So we're in the run position. Hang on. Back in the crank position. Let's run under the hood. Hopefully that stays put again. Set up the camera so you can't see anything. And try this again. Where did my jumper go? Right here. So let's see what happens. So we get a start and die. Usually start and die is theft stuff. And I suppose if this loose, I suppose if you keep the key in the crank position for too long, maybe it'll die. I've never seen that before. Still nothing. So trying to think. Start and die. That's annoying. Start and die is usually a theft related issue. We know the ignition switch. We know the ignition switch feeds the theft module. I'm curious if when this car is working normally, we'll have to do this test if we ever get it fixed. If you just hold it in the crank position for too long, does it start and die? We don't know. We'll test that out. Next test, we're just gonna move everything over to power and grounds on the engine controller and do a similar test that we were doing just now. More saga stuff. So went through looking for powers and grounds. Did two different ways that I check powers and grounds. Print the connector numbers off. So we got on the PCM connector 1, connector 2. Then you just go through each individual line, highlight what's power, what's ground, etc. So for now, the yellow is powers and then the blues are grounds. But also, the second way that I check these, set that aside, is to print off the total power distribution diagrams. And so we can go through, and then if you're looking at the redrawn stuff, it makes it a lot easier because you can do Control F on the keyboard and search for engine. So anything highlighted in yellow is going to be the engine control module and then a power feed to it. So we've got a few of those, but we've been looking at this diagram for a while, and in doing it in this way, we get an interesting piece of data that we need to go back and check for sure, because it ties directly from the ignition switch. So engine control module power, depending on whatever you get that pin, that comes from the body control module. So body controller passes through the body controller. Passes through the body controller. I don't know why I didn't pay attention to this earlier. I just ignored this splice. I looked right past it because I looked down here, saw I wanted the theft deterrent stuff, and then blew it off. But now we need to do all the testing we were doing over here. We need to do on this wire. Specifically, I want to do this test first because it deals directly with start-in stuff. So in accessory or run, we should power up this part of the PCM, is what it's saying. So this is going to be my next test before we do the other powers and grounds. Let me get set up on this one. Current setup is channel A coming out of the body controller, channel B coming out of the ignition switch as soon as I connected them. So A and B, they're at 12 volts. So I don't say anything wrong. So this should be 12 volts. We're in the run position. If I switch to accessory, it should do the same thing.
There's accessory, but if I go to off, they should both drop. Why didn't they both drop? Well, actually, maybe they don't both drop. Channel B, whoops. Yeah, they should both drop. Because if we're in the off position, there should be no connection in A or B. Oh, well, that's weird. Channel A. Okay, so that makes sense then. So channel A drops later. That tells me, it says it's pass through. There's an algorithm to pass this through. It's not a direct wire pass through, and we can see that right here in the data. So we get channel B coming out of the ignition switch to drop as soon as that happens. And then what is that? 10 seconds later or so, the body controller drops the signal out. Let's go ahead and play it. So both should be at ground, A and B. They are. So I'm going to go ahead and key to accessory. They both go high. Key to run. They should stay high. They do. Crank, they should both drop out. What the? Okay, so we're starting. Let me, I got to stare at this data for a minute. Let me catch you up. So I have saved, this is an old one. So this waveform was how the scope was previously configured. I saved it, and it was different ignition position statuses. So you probably can't tell in here because it's dark, but good. So when I say good, I mean it just fired up like it just did, and it's in blue. Bad is based off of this scope pattern, and it's in black. So one thing that we kept being curious about is what are these voltages supposed to be from body controller to ignition switch and back? Well, we can rule that out now because, so the top two are blue. When we're in run, it's, we call it 3.9 this whole video, but essentially 4 volts, crank is 3 volts. In the scenario where the engine did not fire, same thing, 4 volts, 3 volts for run crank. That was for this channel C. So channel D, same thing. Blue is good up here at the top, run 4 volts, crank really 4.25 or whatever, it goes up a little bit. In the one when it did, excuse me, this was good. This is what it's like when it just fired up. Black is bad. Black is when it did not fire up. We're 4 volts and 4.22 volts. So we're done with this part of the circuit. Like we can scratch, like I'll just draw a giant line through it. We're done with this part. Everything else is going to have to be focused on here. But this was cool. We still don't know if this line here is our issue, but we have good numbers. We have good 12 to 0 numbers. So we're going to run this test again, like we just did, and then hopefully it's broken now, and we will look at channel B and channel A and see if we have any difference. So let's go ahead and do that. Let's go ahead and play this live, get rid of that. Yeah, so channel A and B are our main concerns. I'm just going to turn channel C and D off because they're still ignition switch to body controller. We don't care about those. These two are our main girls. So let's go into the run position. Run position, we've got about 12 volts. That is what we had last time. Crank, they drop to 0. They do drop to 0. The engine did not start. We are in the cranking position. So I'm going to let go of crank. They go back to 12. So that tells me, let's pause this just so we don't lose it. So the good, run 12, crank 0, run 12, crank 0. And the bad, I could write it in here with a black pen, it's the exact same. So no longer do we care about this line. So this line is behaving the exact same as last time. This line only goes to the run start relay, which it seems to be on every time. Yo, we have finally crossed this off. Holy crap. We still obviously don't know what's wrong with it, but
man, to be able to cross this off, I'm so glad this issue's intermittent. It's like one of the only times I've ever been happy for an intermittent issue, because if it wasn't intermittent, we would have no clue what these are supposed to be. Um, we, yeah, I guess we could kind of suspect this, but anyway, we're now going back to, actually, we don't care about that one. Now we're going to go back to power and ground stuff on the engine controller. We could still potentially have, it's out there. We could still have potentially communication issues between the body controller and the engine controller, or we've got a bad engine controller. Yeah, is this just looking like a bad body controller or a bad engine controller? Let's see. Let's do these power and ground checks and see if something shows up there. One thing I didn't say too clearly on this one. So when I loaded up the old scope trace on the bad, when it did not crank, we've got this wire here. So according to the wiring diagram, we got 12 volts coming in, and in either the start and or run position, we should have 12 volts coming out. It should pass through 12 volts. And what I'll say is on the bad one, when it did not start, both run and crank had 12 volts coming through. So that's how we can rule out this. Also, we can rule out, same thing. So the body controller is passing it through like it's supposed to in both run and crank position. When the engine did not start, we had 12 volts. So this is passing during start and run. This is passing voltage all the way through. So yeah, we're done with this part. We're now focusing body controller to engine controller. All right, we have 4 scope channels connected to the engine controller powers, and it looks like there's 3 main powers, and then there's that one pass through that in the crank position. It's the pass through from the body controller. In the crank position is supposed to lose voltage instead of have voltage on it. And okay, we have done our best to repin those. We may have to switch to probes and pierce them. But when I was pushing on these, I got a click under the hood. So I don't know what that means. Key is off. Let's roll the key to the run position. We have no change on 2 of them. I don't know if we have a good signal or not. Let's go crank. We have nothing. And then let's stop this. I'm going to switch to probes, to Phil's probes. I need good data here. We are now Phil's probed in 2 wires. I'm dropping stuff everywhere. We are ignoring channel D now. So channel D, yellow, is from ignition switch pass through to body controller to something for the PCM. And wiring diagram says when we go to crank, it should remove voltage from that circuit, and it does. So I'm not worried about that one anymore. We're going to turn channel D off. We should now have actual voltages on the rest of these. The key is off. We got everything within scale. So let's go to accessory. No change. Let's go to run. Looks like we had bad connections on there. So we've got 12 volts on everything. Crank. The voltage never goes away. So we're not worried about power to this control module now. Turn the key off. The red one should stay high because it's straight from battery. But yeah, we'll just go straight to crank. Everything jumps up like it's supposed to. We have no cranking. So not worried about any of these power circuits. Next step in this process, we're checking grounds. So I got wire coming from B plus going through a 4 amp test lot. And then we're just going to start touching various PCM connectors down there that are ground circuits and see if we got good grounds on them. Just got done checking grounds. Well, one ground for the engine controller. It's got one giant ass ground cable. And at this point, we've got as much time as we're going to put into it. And I'm making a call. But I'm going to show you the reason that I'm going to make this call. There's one thing that we saw in the past, and it didn't click until I was just getting ready to do ground testing, and I didn't think of it this way. So let me bring you back and stare at our stare at our old school wiring diagram that we were using. So you're going to have to follow me like always. So ignition switch, body controller, engine controller, starter relay. We knocked all that stuff off. We're done with that. Remember, the ignition switch. This is important. The ignition switch, the physical wires exclusively for here go to the body controller. That's it. That's where it goes. The only way the engine controller can know the key position is through the CAN data line. The only way that it can know this is from CAN communication from body controller. So, engine control module, active test, starter relay. We know we did this with a key and blah, 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 blah. Oh, yeah, I gotta turn the key on. So let's escape. Let's do this again. Starter relay. So we know we were looking at the relay commands before and we were holding it in the crank position and getting changes. But there's something else important here. We need to scroll down. Where is it? Boom. This. Crank request signal. The only way the engine controller can know what the crank request signal is via CAN communication from the body control module. So if I go now to crank, it says yes. This has to come from CAN. The body controller's telling the engine controller to start, and it's not. That is my call. I'm going to call an engine computer on it. Now, I document all this stuff with pictures and videos, well, mostly pictures for customers anyway, but I'm going to give him a total recap of everything that we have done, and I'm going to tell him, really, based on all the testing we've done, and really just the final nail for me to call it is this right here. The only way, again, service info is right, the only way the engine computer can know to crank the engine or that the key is in the crank position is from CAN. So if it's getting the request and it is not providing control power to the control side of the relay, which it's not, and we know the relay works because every time I've tried to do a manual bypass test, we were only controlling the control side of the relay, and it trips every time we do wire jumping. So I know the relay is good. We know the circuitry is good. Somewhere between CAN communication and starter relay control output is an issue. And the only thing there that could be the issue is the engine computer. That's it. It's the only thing between the CAN lines and this output. So I'm calling the computer. If this doesn't fix it, I have no idea what's wrong with it. I have absolutely no clue. Because I always ask, I'm going to lean on what Eric says, like, well, if this doesn't fix it, ask yourself, then what? And my answer, if this doesn't fix it, I don't know. I have no effing clue what's wrong with it if it's not a computer. This is the only data that's pointing us in that direction. I have no idea. I don't know what else I would replace if it wasn't a computer. Like I have no clue what else would be replaced. No clue. There's nothing else in the system. Like that's it. Like we as far as it goes, there's not that many components in the system really, and we've tested everything that we can test. So I know I'm just rambling off on the internet, but I'm making the call. We're going to call a customer. Well, everybody might be closed there. We're going to call a customer, tell them what we got. We're going to find PCM quotes, and then we can do a swap and a flash. I'll bring you back afterwards, and we'll see how she goes. But this is my call. New day. We have our new, used, refurbished, whatever PCM. So apparently I don't make them new anymore. This one's straight from the dealer, and they're all refurbished. So I was wondering why it was a little bit cheaper than I was used to seeing. Dealer price was actually cheaper than aftermarket prices for new, refurbished, whatever. So we got her in here. We got the VCMI USB to the laptop, USB to a long cable that goes into my router. I don't have all the software for these, so I usually just let somebody else remote into the laptop and or the Autel, and then they just flash it through there as a pass-through. So he wants to start with this one plugged in. We're going to throw it in there and let her get flashed, and I'll come back after that's done. This is my happy face. So we got it programmed. We got the this one has a like theft relearn that you got to do, but I'm used to seeing the ones we got to do like 3 or 4 ignition cycles, like 10-minute key on or whatever. This one I only had to do one and it fired up. So let's get you switched. Here's what we got. Key is on. We're gonna crank. Booyah! Boom. We do have. Is that super loud? So we do have the only code left is crankshaft position not learned, so we got to relearn that. I don't think you guys, well, maybe you want to see it. We'll see if I can find it quickly here. I don't know if I need to warm the engine up to do this. Crankshaft position learn. Accelerate to wide open throttle. Release the throttle if cutoff occurs. Refer to relevant info, blah, blah, blah. So we'll hit continue. Engine acceleration should not, well, I can't control that. I'm not a calibrator anymore. Lock the drive wheels. Ignition from off to on. We did just do that. But I'll turn the key off. When I was reading through service infos and stuff, it locks the 30-second key off, so supposedly that should be enough time for the PCM to go to sleep. So we're going to pause at our 30-second mark. We have waited our 30 seconds or so. So apply and hold down brake pedal. Apparently this is a 2-footer. So brake pedal, start engine, turn AC off, vehicle in park. Oh yeah. Wait for minimum coolant temperature. We'll come back. I got to somewhere around 158 and it switched to accelerate to watt and release if fuel cutoff occurs. That's weird. Oh, well, that was fun. I thought it was doing something weird. Okay, let's recap what just happened. I accelerated to watt. We got our first fuel cut, and I let off the pedal, and it stayed at watt, and I couldn't figure out what happened. I tried hitting the accelerator pedal again. Nothing happened. I hit the brake pedal, and then I heard the accelerator click. So I don't know if you can see down here. Probably not. Let's turn this thing off. That was entertaining. I'm pretty sure here's what happened. Turn that off. So I've always seen this online, and I've never actually had it happen in person. There it is. When I jammed that to the floor, it got cut on the freaking floor mat. There it goes. So that's why it stayed at watt. Apparently, we got to be careful with these floor mats. Lesson to self. Anyway, let's go read our trouble codes. This failed this ignition since cleared. I wonder if it didn't do it right. I don't know. Let's try and erase it. Yes. Reading codes. No codes. Heck yeah. So we'll key her off and I'll just see. Boom. She's running. While she's running, I'm gonna hit read again one more time. Boom! We got a fix. Leaking up under the hood, so we got our new controller hanging out down there. I haven't installed it yet. Still got to put the cap back on, and we did, if you remember, we did Phil's probe these wires on this harness when we were checking powers to this engine controller. So I'm gonna get some liquid electrical tape. We're gonna dab it on where I was probing through those wires and make sure we don't have any issues there. Put our connector back on, install it, and then after that, it's just this truck will be ready to go. This customer can come have it. Back to my happy face. I'm always excited when we have a successful PCM flash and no issues afterwards. Every time we do a module replacement, at least for me, every time, no matter how much diagnostics we've done or I've done, I should speak to myself, I'm always in the back of my mind thinking, man, what if this doesn't fix it? What if this doesn't fix it? Like, I got no idea where to go. But that's not the case on this one. This is why I do so much testing ahead of time. This is an expensive bill for the customer, especially since I don't have all of the manufacturer specific stuff. I contract flashing out. It's more expensive per unit for that to happen. So I need to be really careful to make sure that we got the right diag when we're doing module replacement. But I'm super excited. I'm super happy. This made my day. Just I always love having a good fix like this, especially when it comes to module replacements. I'm just blowing steam now, but man, always in the back of my mind when I'm replacing a module, I'm like, man, it can't be a module. It can't be a module. There's got to be something else. What did I miss? What did I miss? But that's not the case. We got a bad module here, and it runs, and we're doing well. Hopefully, it's got enough fuel to make it to the fuel station, so they don't have to tow it there. But anyway, that's it. That's all I got for this video. Hope this was helpful to someone, and yeah, that's all we got for you in this video. So I'll catch y'all up in the next one.